Okay, today I'm gonna be explaining question 2 from homework number 3. For questions 2, we start with part A. Part A says the following. A cyclist going around a circular track at 10 meters per second has a centripetal acceleration of 5 meters per second squared. What is the radius of the curve? So first we see that let's see what we have. So let me put down what we have. First, they give us the acceleration, which is going to be 5 meters per second square. And then they gave us the speed. Let's put that here. And then meters per second. So now when we look at a chapter, we can see that for chapter 3, we're starting to use the radius and the centripetal acceleration. So for the formula that I'm gonna use is the one that we have in the modules, which is gonna be the following formula. Is the one that it's gonna get us the centripetal acceleration. But since we already have that, we're just gonna plug in what we have and see what we don't have. So what they're asking us for the radius, we don't have that. So we're just going to plug in the values that we have. And then we're going to solve for this so we can find it. So let me plug that in. Then we have our speed or initial velocity times square. Then we don't have the radius. So that's what we're finding. So to get that to the other side, I'm going to multiply. Then when I put it to this side, we're just going to divide. We're going to square this and then divide by 5. So our final answer is going to be 20 meters. That's going to be our first answer for part A, 20 meters. Now for part B, they're asking us, let's see what they're asking us. A race car is moving at 40 meters per second around a circular track of radius 265 meters. Calculate the period of motion. So let's see what we have. For part B, we have the initial velocity, which is the 40 meters square. And then in this case, they gave us the radius. The radius is going to be 265 meters. So now we're going to use a similar formula, but in this one, since they're asking us for the period of the motion, we're going to use a formula that includes that. So let's put this here. This one, it's going to be velocity equals 2 pi times radius over period. So let's plug it in what we have. We have the velocity. Let's do 2 times pi. Then we have our radius, 265, over the period, which is what we want to have. Fine. So we're going to just do what we did in the last part A. We're just going to solve for t. Move that to the other side. Multiply that in our calculator. When we multiply that, let's see what we get. Pi 265. 265. We're going to get this. And then we're going to divide that by 40 meters square. This is meters. So this cancels out. This cancels out. And then we found that for time or a period of motion, it's going to be 41.6 seconds. So this is going to be part B. All right. So let's see part C, what they're asking us. It's going to be with the same values, but now they're asking us to calculate the car's centripetal acceleration. So we're going to use the same formula that we use, a similar formula. So the formula is going to be the following. Acceleration, centripetal acceleration. It's going to be velocity squared divided by a radius. So let's find that. Our centripetal acceleration, it's gonna be, let's plug those numbers in so we know that velocity is 40 square, and then our radius is 265 meters. When we put that in our calculator, we're gonna get there. Our final answer is gonna be 6.4 meters squared. That's gonna be part C. These questions are kind of similar and easy because we just have to plug it into our formula. So now let's start with part D. For part D, they're saying the wheel of a stationary exercise bicycle at your gym makes one rotation to 0.670 seconds. Consider 2 points on this wheel. Point P is 10 centimeters from the rotation axis, and point Q is 20 centimeters from the rotation axis. Find the speed of point P on the spinning wheel. So when I have a question like that, I always like to first make like a free body diagram. So let's see what they say. Okay. So first they're asking us to find the speed of point P. So point P is 10 centimeters from the rotation axis. So this is point P right here. It's 10, but since we have to use meters, we have to convert that to meters. So 10 centimeters, let's convert that centimeters to meters. When we convert that, it's gonna be, this is gonna be 0.1 meters. Okay, so now since they're asking us for the speed, we also have the time. So period, it's gonna be 0.670 seconds. So we can just use the formula that we used before in part, I think it was C, which is gonna be the following to get the speed. 2 times t. Then here we're gonna put this, which is what we have right here, and then under this we're gonna put our time. It's 70. Okay, so the speed of point P on the spinning wheel, it's gonna be, when we plug that into our calculator, we get that this give us 0.94 meters per second. And then now for part E, they're asking us to find the speed as well of point Q. So let me do that again, another circle. Let's see, so point Q, let's see what was the, and point Q is 20 centimeters from the rotation axis. So let's do 20 centimeters. Now let's do that from centimeters to meters. That's gonna be 0.2 meters. And then we're using the same time, same period, which is gonna be 0.670 seconds. And then basically we're just gonna use the same formula that we used before. So let's plug that in. Let's plug our numbers in. 2 pi times 0.2 meters over 0.67 seconds. Let's plug that into our calculator. And then we're gonna see that our velocity for point Q, it's gonna be 1.88 meters per second. For next questions, they're asking us find the centripetal acceleration of point P. Okay, so for part F, let's write it down. They're asking us to find the centripetal acceleration. So we're just gonna use the formula that we have previously used, which is this one, velocity square, and the radius. So let's plug that in for part F, and we're gonna use our point P. This was P, and this was Q. Okay, so let's find P first. So I'm gonna put the velocity for P was 0.94 meters square. And then under we have a radius, which is they give us to us in the last question. And then when we do this in our calculator, we're gonna get 8.84 meters per square. And then this is gonna be for P. This is the centripetal acceleration for point P. Now let's see, the next question is part G. They're asking us to do the same, but we're gonna do it for the point Q now. And this is part G. So we're gonna use just the same formula as well. This formula, acceleration, speed under the radius. So let's use this formula. And that's gonna be our previous velocity was 1.88 meters square. We're gonna square that, and then over the radius, which was 0.2. When we plug that in our calculator, we're gonna get our results are gonna be 17.67 meters per second square. Sorry. Now part H is saying, for points on this spinning wheel, as the distance from the x-axis increases, does the speed and the centripetal acceleration increases or decreases? So let's look at that. When we went from P to Q, did our acceleration increase or decrease? So as we can see, it went from 0.94 to 1.88. So that means this increase. The speed increase. Now let's look at the centripetal acceleration. This is point P and this is point Q. Did it increase or decrease? To me, it seems like increase as well. So we're gonna put that our answer is both the speed and the centripetal acceleration increase. So let me put that here. Both speed and centripetal acceleration increase. They went up. Okay. Now for our next question, it's gonna be part I. What does it say? Let me write it down right here. Okay, part I. It says the following: the planets Venus, Earth, and Mars all move in approximately circular orbits around the sun. Use the data in the table below to find the speed of each planet in its orbit. Okay, so they're giving us the radius for each planet. We also have the days, so we have the time, but we have it in days. So what we're gonna do for each of these planets is that we're gonna convert the dates to seconds, which is what we needed. So let's start with Venus. Venus has 225 days. So we're just gonna do the conversion of that. We're gonna do the conversion. So let's start. Let me start right here. 225 days over 1 times hours for 1 day times 60 minutes, which we're going closer to seconds, times 60 seconds over 1 minute. When we multiply and then we cancel out everything, let's cancel this, the hours and this with this, the minutes with the minutes, we're left with seconds. So we're left with a pretty small number. It's gonna be 1.944 and then times 7 seconds. It's not going to be times 7. It's just scientific notation. So I'm just going to leave it like that for now. And now we're asking us to get the speed of each. So let's use the formula. We know that we have the radius. We know that we have the time. So maybe we can find a formula that we can solve for this to get the speed. So let's use this one right here. So let's solve for b. And then let's put 2 pi times our radius. They give us to us in the question. And this is the radius, 1.08. Scientific notation. Over the seconds that we found previously. We're going to plug that in our calculator. And then we're going to find that our velocity is going to be this number. But they're asking us in the question to get the velocity to be kilometers per second. So now we're going to move it from meters per second to kilometers. And this means we're just going to move a decimal number. So this is going to be the one for Venus. So this is the speed for Venus. Now let's go with the second planet, which is going to be Earth, the planet Earth. So let's do the same to find the seconds. In this case, we have 365 days. So let's convert that to seconds again. So we're just going to do the same times hours over days. So we can cancel that out. Times minutes, 60 minutes for 1 hour. And then times seconds, which is what we want. Over 1. We cancel out, we multiply. And then we are left with seconds. And our answer is going to be 3.53. Scientific notation. And then this is seconds. Alright, so let's plug it in into the same formula. Now, for this, we have a radius of 1.50. Let's plug that in again. The scientific notation over our seconds, 3.53. And now we have our velocity. Our velocity is going to be meters per second. But we have to convert that to kilometers per second. So let's go ahead and do that right now. And then when we do that, we can see that our velocity in kilometers per second is going to be 29.89 kilometers per second. Now we have Mars. Okay, for Mars, we're going to do the same. We have 687 days. So let's plug that in and do it right now. 24 hours, 1 day, times 60 minutes, 1 hour, times 60 seconds, for 1 minute. Our final result is going to be 5.936. The scientific notation, seconds. And now we're going to plug into our calculator. So let's into a formula and then enter our calculator. So we have the radius, which they gave us to us, is 2.2. Scientific notation over the seconds that we got, which is going to be 5.936 seconds. And then our velocity is going to be meters per second, sorry. So we have to get that to kilometers per second. So let's go ahead and do that, which we only have to move a decimal, and then we get that our answer is gonna be 24.13 kilometers per second. When we plug that in, we see that our speeds of, we have the speed of Venus, we have the speed of Earth, and we have the speed of Mars. Okay, so we found every single one. Let's go ahead with our next question. Our next question says the following. Part J. Use the data in the table above to find the centripetal acceleration of each of the planets. So this is really easy because what we have to do now is just plug in into our formula. So the same formula that we have previously used for all the questions, we're just gonna do the same. So Venus, since we already have the time, we already have the radius, this is gonna be pretty easy. We just plug in our numbers. So we have the first one, and then 6.5a square over the radius times 10. The centripetal acceleration for Venus is going to be 0.0113 meters per second square. Now let's do the one for Earth. Let's start with this. Now for the Earth one, we have our seconds, or our speed, I should say, square over our radius. And then when we plug that into our calculator, we get that the centripetal acceleration for the Earth, it's going to be 0.0060 meters square. Now for Mars, we have the following. We have our speed, which is what we found in the last question. We can square that, and then we have our radius, 20 times 10. Then we finally could plug that into the calculator, and we get 0.0026 meters square. So now we just found the speed and the centripetal acceleration for each of the planets. For part K, then asking us, as the size of planets' orbits increases, do the speed and the centripetal acceleration increases or decreases? So let's go look at the speed. So when we look at Venus, it starts from 39. Then when we go to the Earth, it goes to 29. Then we go to Mars, and it goes to 24. So when we see a pattern, we can see that the speed decreases. And then let's go look at our centripetal acceleration. And then we go from 0.0113 meters per second, then to a smaller number, and then to even a smaller number. So that means that both the speed and centripetal acceleration are going to decrease, or are decreasing. Alright, so we just have that. Let's look at our next question. Our next question is, object A is moving at a speed v in a circle of radius r. Object B is moving at a speed 2b in a circle of radius r over 2. What is the radius of the period of object? I'm confused. Of object A to the period of object B. So we've done a couple of these questions before in previous homeworks, and basically these questions are like just algebra. You just have to plug in and solve. So let's see what we have right now. So this is gonna be part L. What do we have for part L? They're telling us the speed is meters per second. So let's see what we have. So let's put that our speed is the same, meters per second. We know that our final is going to be meters. One is to find time. Okay, so let's plug that into a formula that we used before. Let's see. Over V. Okay, so let's see. They're asking us, what is the radio? Okay, so let's start plugging in to find our radio. So for that, we need to find both of them, for object A first and then for object B. So let me start with object A first. So okay, let's find period for object A. So we know that speed is gonna be the value that they gave us. And then let's put that over here, which is what we're solving for. Then we're gonna cancel that out so we can put it to the other side. And then we have this 2 pi over r this side, because we're gonna move this here. So once we have this, we can get that time for the object A is gonna be 2 pi r over b. Okay, so now we're gonna do that. This is for object A. Let's put it right here. So now let's do that for object B. So for object B, we have different values. So let's plug that in. Let's plug this. This is our formula. And then for object B, we can just plug in what we have, which is gonna be, we know that radius is gonna be radius over 2 in this case. And we plug that in, cancel out, move to the other side. We have this, and we're left with pi over pi times r. But then we have to get this to the other side. So we have that time of b is gonna be pi r over 2b. And now we just have to put these two together into our radio. So let's do that right now. We have the one that we found for object A, and we have the one that we found for object B. So let's do that right now. We have right here the first one for object A, and we have the second one for object B. So when we're dividing, we just now have to like multiply so we can cancel out, so we can get rid of some things. So this one, we're gonna flip it so we can actually cancel out a lot of things. So we cancel this out, cancel this out, cancel this out, cancel velocity, velocity, and what are we left with? We're left with 2 times 2. So we get that the radio of object A and the object B is gonna be 4. 4. Now, for part M, they're asking us for the radio of the centripetal acceleration of object A to the centripetal acceleration of object B. Okay, so for this, we're using the same values, but now they're asking us for the centripetal acceleration. So let's go ahead and do that. So let's do that. This is part M. We know that we already have this. This is going to be for object A, and this is for object B. So now we just have to plug it in into our formula. Our formula is this. So let's see. So for the centripetal acceleration for part B is going to be the following. Let me just plug that in what we have. Square, and then we know radius is r over 2 equals 8b squared radius. Now we're going to divide this. Square by r2, and now it's just basically our multiplying, so we can just plug that in into our equation to find a radius. So So let me plug that in. So for part A, we know that the centripetal is going to be the same one. But for part B, we already got it, and it was 8b squared over r2. So what I like to do is just like multiply so we can cancel out. So this is the first one, and then we flip the second one. And that's going to left us with this. Then we cancel this out. And then we're left with 1 over 8. So our answer for part M is going to be 1 over 8. We can also get the decimal, which is going to be 0.125. And that's all.